teach you the derivative of a function, that is the product of a two function. How will you find out the derivative of the product of a two function? Now see, all of you please be attentive. Now see here, let f of x is equal to x sin x. Now there is a product of a two function, one x and another is the sin x. Now you have to find out, find f dash x. Find f dash x. Now whenever there is a derivative of a product of the two function, now what is the rules here? The ddx of, suppose there are the two functions u and v, then u remain as it is, take the derivative of u, plus v remain as it is, take the derivative of u. By using the same rule, that is f dash x means ddx of f of x, and the ddx of f of x, it is nothing but x sin x. Now here we can take any function as a u and any function as a v. Now let us consider x remain as it is. Take ddx of sin x plus sin x remain as it is. Take ddx of x. X as it is. The derivative of a sin x, that is cos x. Sin x remain as it is, and the derivative of x, that is equal to 1. Therefore, x cos x plus sin x. Now this is the first example. Again I will take second example. F of x is equal to, suppose, log of x and root x. Now see, f dash x means ddx of f of x, and the ddx of f of x is log x into root x. Log of x remain as it is. ddx of root x remain as it is. ddx of log x. Log of x remain as it is. The derivative of a root x, 1 upon 2 root x, plus root x remain as it is, and the derivative of a log x, that is 1 by x. Again, log x divided by 2 root x remain as it is. Here, the root x remain as it is. This x you can write as a root x into root x. 1 root x get cancelled. Log x divided by 2 root x plus 1 upon root x. Here again, 2 root x. The LCM. 2 root x remain as it is here. Again, log x. If you divide it with root x to this LCM, what is remain? 2. Again, 2 into 1, that is 2. Therefore, 2 plus log x divided by 2 root x. Therefore, f dash x is equal to 2 plus log x divided by 2 root x. Again, I am going to take the third example. See, the third example. Here, ddx of 2x plus 3, 5x minus 4. Here again, let us continue. Now again there are the two functions. Again one function remain as it is. 2x plus 3 remain as it is. ddx of 5x minus 4 plus 5x minus 4 remain as it is. ddx of 2x plus 3. Here 2x plus 3. When the constant, it is multiplied to the function, constant remain as it is, and the derivative of a x, that is 1, and the derivative of a constant, that is 0. Therefore here the derivative of a 5x minus 4, that is equal to 5. Again 5x minus 4 remain as it is. Take derivative of a 2x plus 3. Again 2, that is the constant. When the constant, it is multiplied to the function, constant remain as it is, and the derivative of x, that is 1, and the constant, the derivative of a constant, that is equal to 0. Multiply with 5. 5 2s are 10, 10x, 30, 10x minus 8. Again 10x plus 10x, 20x, and 30 minus 8, that is equal to 22. So here you have got the ddx of 2x plus 3 into 5x minus 4, it is equal to 20x plus 22. Again, I will take one more example here. Fourth example, ddx of e raised to x and log x. Again, e raised to x remain as it is. ddx of log x plus log x remain as it is. ddx of e raised to x. e raised to x. The derivative of a log x, that is 1 by x. plus log x remain as it is. The derivative of e to the power x, that is e to the power x. Again you can take e to the power x common. What is remain? 1 by x plus log x. Therefore here d dx of e raised to x into log x is equal to e raised to x 1 by x plus log x. Suppose I take the three functions multiplied. F of x is equal to e raised to x, sin x and log x. How will you find out derivative? Now see again, f dash x is d dx of f of x, d dx of e raised to x, sin x, log x. Now since the three function it is multiplied, what you have to do? First two function you have to keep as a constant, take the derivative of a third function. Again second and third you have to keep constant and take the derivative of a first function. And here again the first and the third function remain as it is, you have to take the derivative of a middle function. Again e raised to x, sin x remain as it is. Take d dx of log x plus sin x, log x remain as it is. Take d dx of e raised to x plus e raised to x, log x remain as it is. Take d dx of sin x, e raised to x, sin x, derivative of a log x, that is 1 by x, sin x, log x, again e raised to x, derivative e raised to x, again e raised to x, log x remain as it is, and the derivative of x, sin x, that is cos x. Got it? So we can find out the derivative of the product of the two functions, the derivative of the product of a two function. We can take many examples here. The rule is that one function remain as it is, take the derivative of another function first plus second function remain as it is, and then take the derivative of a first function. Right? Again I will take one more example here. See the fifth example. d dx of 2x plus 4 into cot x. Again 2x plus 4 remain as it is. d dx of cot x plus cot x remain as it is. d dx of 2x plus 4. 2x plus 4 remain as it is. The derivative of a cot x, that is minus cosec square x. This you have to write in bracket. Don't write simply minus cosec square x. That becomes the wrong meaning here, cot x. And the derivative of a 2x, that is 2. And here the derivative of a 4, that is 0. Therefore here minus cosec square x, 2x plus 4 plus 2 cot x. In this way we can find out the derivative of the product of a two function. Now I will take the derivative of the two function which is in quotient form. Now again, if the function it is in a quotient form, see the rule d dx of u by v. That is, here the denominator remain as it is, v remain as it is. Take the derivative of a numerator. You have to keep minus sign, minus remain as it is. Again, numerator remain as it is, take the derivative of a denominator divided by denominator square, where denominator should not be equal to 0. Again, here, first you have to keep the denominator constant, denominator remain as it is, take the derivative of a numerator minus numerator constant, take the derivative of a denominator divided by denominator square. Now take one more example, simple example. I will take sin x divided by root x. Here root x remain as it is, denominator remain as it is, d dx of sin x minus sin x remain as it is, take d dx of root x divided by root x whole square. Here again root x, the derivative of sin x, that is cos x, minus sin x remain as it is, the derivative of root x, that is 2 root x divided by root x whole square, that is x. Again, by cross multiplication, 2 root x into root x, that is 2x cos x minus sin x divided by 2 root x. Divided by x means into x. Therefore, here you have got the ddx of sin x divided by root x is 2x cos x minus sin x divided by 2x root x. This is the simple method here. That is the simple rule u by v. Isn't it? Again here, denominator remain as it is. Take the derivative of numerator minus numerator remain as it is. Take the derivative of denominator divided by denominator square. Again take one more example. Here, ddx of sin x plus cos x divided by sin x minus cos x. Now see, here again, denominator remain as it is, sin x minus cos x remain as it is. ddx of sin x plus cos x minus sin x plus cos x remain as it is. Take ddx of sin x minus cos x divided by sin x minus cos x whole square. Here again, simplify. Sin x minus cos x remain as it is. Again, the derivative of sin x cos x and the derivative of cos x minus sin x. Here minus sin x plus cos x remain as it is. The derivative of sin x, that is cos x, and the derivative of cos x minus sin x, this minus that minus, minus minus plus, divided by sin x minus cos x whole square. Again, if you observe this, suppose you take minus sign common, here you will get cos x minus sin x, cos x minus sin x, here you can write cos x minus sin x whole square. Again, sin x plus cos x, sin x plus cos x, that is sin x plus cos x whole square. Sin x minus cos x whole square. Now, if you simplify this, again you can take minus sign common. If you take minus sign common, cos x plus minus sin x whole square plus sin x plus cos x whole square, cos x minus sin x whole square plus sin x plus cos x whole square divided by sin x minus cos x whole square. Keep minus sign remain as it is. Here again, in bracket, a minus b whole square means square of a first term minus twice the multiplication of a two term plus the square of a second term. In the same way, cos square x minus 2 sin x cos x plus sin square x. Again, same rule you have to apply. Sin square x plus 2 sin x cos x plus cos square x divided by sin x minus cos x whole square minus sin square x cos square x plus sin square x 1 minus 2 sin x cos x. 2 sin x cos x, that is the formula of a sin 2x. Here again, sin square x plus cos square x 1. Again 2 sin x cos x, that is the formula of a sin 2x divided by sin. Again, if you simplify this, sin square x minus 2 sin x cos x plus cos square x. Here, minus sin 2x plus sin 2x get cancelled. 1 plus 1, 2 means minus 2. Here again, sin square x plus cos square x 1 minus 2 sin x cos x. This is the formula of a sin 2x. So, here you have got minus 2 divided by 1 minus sin 2x. This is the division rule. Here, see again what you have to do. Again, sin x minus cos x, denominator remain as it is. Take the derivative of a numerator, sin x plus cos x. minus sin x plus cos x remain as it is. Take the derivative of a denominator ddx of sin x minus cos x and divide it by denominator square means sin x minus cos x whole square. Again sin x minus cos x remain as it is. The derivative of a sin x, that is cos x. The derivative of a cos x, that is minus sin x. Minus sin remain as it is. Sin x plus cos x remain as it is. The derivative of a sin x, that is cos x, and the derivative of a cos x, that is minus sin x. This minus, that minus, minus minus plus, again denominator square remain as it is. Again, if you take minus sign common from the first bracket, you will get cos x minus sin x. Second bracket cos x minus sin x, therefore cos x minus sin x whole square. And here again the same bracket, sin x plus cos x, sin x plus cos x. Therefore again I have made here the sin x plus cos x whole square. This is minus, this is minus. You can take minus sign common and in bracket you can write cos x minus sin x whole square plus sin x plus cos x whole square divided by denominator square. Now simplify the bracket. Minus sign remain as it is. You have to simplify, you have to expand by the formula a minus b whole square means the square of a first term twice the multiplication of a two term plus the square of a second term. Here also same, you have to use the formula a plus b whole square, sin square plus 2 sin x cos x plus cos square x. Again cos square x plus sin square x 1, 2 sin x cos x, this is the formula of a sin 2x, sin square x plus cos square x 1 and 2 sin x cos x, this is the formula of a sin 2x. So minus n plus minus sin 2x plus sin 2x get cancelled, 1 plus 1 2, and again you can simplify the denominator also. In the denominator again you have got 1 minus sin 2x. So the result is minus 2 divided by 1 minus sin 2x. Right? Again take the another example. F of x is equal to sin x divided by 1 plus cos x. Find f dash x. Same rule you have to apply here. See, f dash x means d dx of f of x, d dx of sin x divided by 1 plus cos x. Again, here denominator remain as it is. Take the derivative of the numerator. Here again denominator, that is 1 plus cos x remain as it is. Take d dx of sin x minus sin x remain as it is, d dx of 1 plus cos x divided by 1 plus cos x whole square. So denominator remain as it is. Take the derivative of the numerator minus numerator as it is. Take the derivative of the denominator divided by denominator square. 1 plus cos x. The derivative of sin x, that is cos x, minus sin x remain as it is. Here the derivative of 1 0, cos x the derivative minus sin x. Here again 1 plus cos x whole square remain as it is. You can multiply with cos x to this bracket and open the bracket. Cos x into 1 cos x, cos x into cos x cos square x, minus minus plus sin square x. Here 1 plus cos x whole square. Sin square x plus cos square x 1 plus cos x divided by 1 plus cos x whole square. This get cancelled, 1 upon 1 plus cos x. Here again 1 plus cos x, the evergreen formula, that is 2 sin square, 2 cos square x by 2, 2 cos square x by 2. Again 1 by 2 remain as it is, and cos square x by 2 you can write as a sec square x by 2. Again, this is also the answer and this is also the answer. There are the two answers, that is 1 upon 1 plus cos x, or that you can write as a 1 by 2 sec square x by 2. Again take another example here. F of x is equal to 1 minus sin x divided by 1 plus sin x. Here again denominator, find f dash x. d dx of f of x is equal to f dash x. Therefore d dx of 1 minus sin x divided by 1 plus sin x. 1 plus sin x, d dx of 1 minus sin x minus 1 minus sin x remain as it is. ddx of 1 plus sin x divided by 1 plus sin x whole square. Here 1 plus sin x, the derivative of a 1 0, the derivative of a sin x that is equal to cos x minus cos x remain as it is, minus 1 minus sin x. Again the derivative of a 1 0 sin x cos x divided by 1 plus sin x whole square. Here again multiply with minus cos x to this bracket and open the bracket. 1 into minus cos x minus sin x cos x. Again you have to multiply with minus sin as well as cos x. Minus cos x into 1 minus cos x and minus plus sin x cos x. Sin x cos x divided by 1 plus sin x whole square. Again sin x cos x plus sin x cos x minus sin x cos x get cancelled. Minus cos x minus 2 cos x divided by 1 plus sin x whole square. Again this is the third example. Again I will take one example here. F of x is equal to x cos x divided by log x. Take again one example here. Division rule. Find f dash x. F dash x ddx of x cos x divided by log x. Again denominator remain as it is, log x remain as it is. ddx of x cos x minus x cos x remain as it is. ddx of log x divided by log x whole square. Log x. Here please be attentive. Now what you have to do, x cos x means here there is a multiplication of a two function, apply the product rule. Again x remain as it is, take ddx of cos x plus cos x remain as it is, take ddx of x and the bracket close. You have to write the expansion, the derivative of a x cos x in bracket here, minus x cos x remain as it is, and the derivative of a log x that is 1 by x divided by log x whole square. Now simplify the bracket. Log x remain as it is. Here again x, the derivative of a cos x minus sin x plus cos x, the derivative of a x 1, x get cancelled, minus cos x divided by log x whole square. Multiply with log x to this bracket and open the bracket here. Minus x log x sin x plus cos x log x minus cos x log x divided by log x whole square. So this is the third example of a division rule. बंद कर.
वरचं दाबायचं का?
बंद तिथलं बंद कर म्हटले ना मॅडम, ते लाल वाला